Welcome back, everyone. This is actually my first video on the channel, and today we're actually going to learn how to solve discriminants using a complex example. So our example is here, and we're going to actually do the example 3x squared plus 3x plus 1 equals 0. So this example that I wrote here is actually a quadratic equation, and by using the discriminant to solve this, we can actually find out if it's a complex example or not. And by doing that, we actually have to know one formula. And that formula is d equals b squared minus 4ac. And the reason why we want to know this is because this is out of a quadratic equation. And here, let me write that down. So if we actually have a quadratic equation, and the quadratic equation equals x equals negative b plus minus square root b squared minus 4ac all over 2a. We want to look at the discriminant. And the discriminant is this part inside the square root. By getting that, we can take that out and make it into the discriminant, which is d equals b squared minus 4ac. That's basically just what we did. We took this part out of the square root and we made it into here, b squared minus 4ac. And now that you understand that, we can actually get to this question. So it's asking us d equals b squared minus 4ac. So 3x squared plus 3x plus 1 equals 0. So we have to determine the value of the discriminant and state the type of solution. The given equation right here. So we're going to do that right now. So at the bottom, or actually at the side, we can write it down here. So it is 3x squared plus 3x plus 1 equals 0. So by doing that, we have to find the a. What equals what? Here, I'll write this down on the other side. We can find out what a equals, what b equals, and what c equals in order to solve for b, a, and c all in this discriminant. So if you look here, a, b, c, b equals 3, a equals 3, and c equals 1. So now that we have all our components, we can use this equation right here to solve this question. So let's start this again. B squared minus 4ac. B squared, so that's 3 squared, minus 4 times a times c times 3 times 1 equals 0. So now we have that, we can do the solving. So that's 9 minus 12, which is actually a discriminant. So 9 minus 12 is actually less than 0. And we can tell that because negative 3 is actually less than 0. And by solving for that, we know that negative 3 is less than 0. Right here, it says 9 minus 12. That's 9 minus 4 times 3 times 1. Since 9 minus 12, negative 3 is minus 0. So this was actually a complex solution, or a complex example for solving discriminants. As you see, we used our a, b, c to solve in, subbing in the b squared minus 4ac to get this example. Thank you for watching.